Okay, so let's have a look at this question. This is part 2 and we're probably going to be ending HCF and LCM with a few past paper questions. Now the question is 48p is a square number. Find the smallest possible value for p. Basically, the concept over here is that you're supposed to prime factorize the number given, which is in this case 48, and what you're going to do after that is you're going to see when you're factorizing it, remember to put it in squares. Like for example, if I find the prime factors of 48 on this side, okay, prime factors of 48 right here, so 48 divided by 2, that would be 24. 24 once again is divisible by 2. I'm doing the prime factorization right now. Is 12. 12 divisible by 2 again is 6. Divide by 2 again is 3. And divide by 3 once more is 1. Right? So we have 1 at the end. That means the prime factorization is done. You're going to write these as pairs of squares because you're looking for a square number. So if I write 48 and I write it as 2 square times 2 square times 3, it's still 48, because if you multiply all of these numbers again, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, and 16 times 3 is 48. So they will give you 48 again. So it's just different form of writing the same thing. Okay? Remember, opposite things can be cancelled out, like square and square root would cancel out. So practically everything would cancel out. The square of 2 would cancel out with the square root. The square of this 2 would also cancel out with the square root, because you have 2 squared times 2 squared. But the 3 is going to be troublesome because the 3 doesn't have a square. So the value of p is going to be the extra 3 you multiply by choice to have it become a square number. And you can check as well. Let's have a look. After you cancel out the square and the square root, you are left with 2 times, let me just write it down, 2 times 2 times 3, which gives you 2 times 2 is 4, 4 times 3 is 12. Okay, so technically 12 was our number after we square rooted. And let's check, we added another 3, so that was 48 multiplied by 3, because 48p, that's 144. So if this is 3, so 48 times 3 is 144, and when you square root 144, you can check using the calculator, you get 12. So that's how it proves it. Okay, it could be more than one numbers as well. It always doesn't mean it's going to be one number that you're multiplying. So let's have a look at this question and let's try it out together. This one, just let me copy it down. Okay, well, let's just copy it right here, take it back, and let's have a look. Okay, this is the question. 90p is a square number. Find the smallest possible value for 90q. 90q is a square number. Find the smallest possible value for q. So what you're going to do first is do the prime factorization, because it's the same thing, just in a different form. So it makes it easier for us to decide. So it's going to be divided by 2, which is going to give you 45. Now 45 is an odd number, not divisible by 2, but is divisible by 3. Okay, or you can even divide it by 5. It doesn't matter. Both are prime numbers, your choice. If you think you can't get to 45, you can't remember if 45 is a part of the table of 3, you can divide by 5. Doesn't matter. Okay, the order doesn't matter. Just only divide by prime numbers. So I'll divide by 3, that will give me 15. Then 15 is divisible by 3 again, because 3 times 5 is 15, so you have a 5. And then divisible by 5 again, you get a 1 at the end. You're going to put all the numbers which can be put as pairs of squares. So you're going to put them as squares. So instead of writing 90, q, basically q is a square number, so it's a perfect square. I'm going to write 2 times 3 square times 5. Now this square and this square root will cancel out, but the problem is that this 2 doesn't have another 2 to make it a square, and this 5 doesn't have another 5 to make it a square, so I can cancel out the square. So the new number that I'm going to introduce into my equation is going to be another 2 by choice, and then I'm going to multiply another 5 by choice, which will end up making this 5 and this 5 square, and it will end up making this 2 and this 2 square. So this will cancel out square, square root cancel out, square and square root cancel out. So you are now left with, what are the two numbers you multiplied on your own? You multiplied another 2 on your own, and you multiplied another 5 on your own. So your value of q is going to be not 2 and 5, it's going to be 10, because you multiplied 2 and 5, so that gives you 10. Got it? these are the two numbers you multiplied by yourself. Now let's have a check as well. 90 times 10, 90 cube means 90 times q, 90 times 10 is 900. Square root of 900 is 30. So it's a perfect square now. Whereas if you check under root 90 is not a perfect square. So here you go, that was the concept. Same concept can be applied to square roots as well. Okay, it could say that it's a perfect cube number as well. But we'll continue to that question after a little bit of practice. So let's have a look at some past paper questions. Let's begin. This is another one for in case you want to try it out later. Okay, you can try it out. Leave the answer in the comments and I'll have a look. Let's have a look at a past paper question now. We have few questions that we're going to try out, starting from this one. Okay, let's have a look now. This is one question we have. It's from a past paper, good one to practice. So let's have a look. The question is written as a product of its prime numbers. 168 is equals to 2 cube times 3 times 7. Now, since the prime factorization is done, and in A part, the first step is to find the prime factors of 140. We'll first simply do that. 140 is going to get divided. I don't have a lot of space, so probably continue on the other side later. So 2 divides by 140 to give you 70, then you divide 2 again to get 35, then you divide 5, I'm going to do that on the other side, you divide 5 right here to get 7, and then you divide a 7 to get 1. So your prime factorization is done. So it's going to be 2 square times 5 times 7, okay, because there are 2 2s. Now they're saying find the highest common factor, HCF of 168 and 48. If you remember, as per our discussion, if you had the prime factorization already given to you, or if they asked you in one part to find the prime factorization, you're going to use the method where you make the loops or the pairs and find the HCF, okay. For revision purposes, I'll do it with you guys. This is going to become 168 is equals to 2. You're going to write it in expanded form. 2 times 2 times 2 times 3 times 7. And 140 is equals to 2 times 2 times 5 times 7. Now for HCF, as discussed, theek hai, pehle bhi, you're going to make pairs of like numbers. So here's a one pair, here's another pair, and here's another pair, and you're going to pick one number from each pair, which will end up giving you 1 2 from this pair, that's going to give you 2, another 2 from this pair, that's going to give you times by 2 again, and a 7 from this pair, so that's going to give you times by 7. So 2 times 2 is 4, 4 times 7 is 28. So the HCF of both these numbers is 28, and you're done. Now C part is a fun one. C part is find the smallest positive integer n. Okay, now they've just made the wording a little fancier. Smallest positive integer n, such that 168n is a perfect square. You already luckily have the prime factorization of 168 given to you, so you're going to use it. Less working, more efficiency. Okay, so here it is. All you're going to do is, it's a square, perfect square numbers. You're going to group the numbers into square. So 2 square, that's 2 cube, but you're going to write 2 square times 2. It's the same thing. It's 2 square times 2 is still 2 cube, but you're going to break it down. So if I write it under, it's a square number. So 168n, when I multiply the new numbers of n, it should give me a perfect square number. Let's check. I'm going to write this as 2 square times 2 times 3 times 7. Okay, now 2 square and the square root would cancel out, but we have a little bit of trouble. The trouble is this 2, this 3 and this 7 do not have any squares to cancel with the square root. So that means I need to multiply another 2, I need to multiply another 3, and I need to multiply another 7 to make this transform into 2 square, 3 square and 7 square, so that this and this can all cancel out with the square root, because they're opposite things, they cancel out. So the new number that I actually multiplied are 2, 3 and 7. So the value of n is going to be 2 times 3 times 7, which is 42. And let's have a look as well. 168 n is a square number, so my value of n, they're saying such that n 160n is a square, 160n, find the smallest possible integer n. So let's see if 42 is the correct answer. I'm going to multiply 168 with 42. Okay, that's going to give you can use your calculator for that. That gives you 7056, and the square root of 7056 is going to be, let me square root that gives you 84. So here we go, it is a perfect square now. Okay, so this was the proofing part to prove to you guys that yes, indeed our value of 42 is correct. Okay, all you need to do is you need to write all the numbers in pairs or squares, whichever extra numbers you have, you just write them as it is, and you figure out what other numbers you need to multiply. It could be more than one, in this case there were 3, to get a perfect square, so you can cancel the square and the square root. Okay, and the new numbers you multiplied would be that specific alphabet value. Clear? Let's have a look at another question. I'm going to be doing some questions now, so let's have a look. Now the next question we have at hand is another one. Let's try it together. Here it is. Let's give it a go. A part is very easy, but we're still going to do it for our satisfaction, but we have lots and lots of practice done. Okay. A part is express 198 as a product of its prime factors. So you're simply going to make that a ladder. That's what I'm going to do as well. 198, and I'm going to start to divide 198 now. 198 is a even number, so I can first of all divide it by 2, which will give you 99. Okay, the 99 is definitely divisible by 3, which will give you 33, which is because 3 times 3 is 9 and 3 times 3 is 9. Once again, 33 is again divisible by 3, which will give you 11, and 11, as we all know, is a prime number, so it's going to be divided by 11 to give you 1, and your prime factorization or product of its prime factors is done. So the answer is going to be 2 times 3 square, because there are 2 3's, times 11, and that is your answer. Acha. B part बड़ा simple है, बस थोड़ी सी wording कि we need to get a hang of it, otherwise it's relatively very simple. The B part is find the largest number that divides exactly into m and n. ठीक है, find the largest number that divides exactly into m and n. Now if I'm looking for a number, either it could be HCF, highest common factor, or it could be LCM, which is least common multiple. Multiple is basically आप किसी चीज़ का table पढ़ रहे हो, like multiples of 2 would be 2, 4, 6, 8 and so on and so forth. But factors of, let's say, 4 are going to be 1, 2. That means if I divide 4 by those numbers, like if I divide 4 by 2, I should get a complete whole answer, not a decimal, and there should be no remainder left as well. That's what concept of dividing the largest number exactly is. So in this case, I'm going to go and find the HCF. Okay? If I want to completely divide any number, I will always look for the highest common factor. So I can completely divide these two numbers. Very simple and very easy. Okay, I'm just going to write m in an expanded form. It's going to be 2 times 2 times 3 times 5 times 5, and n is going to be 2 times 2 times 2 times 3 times 3 times 7. Okay, they've been written in expanded form. Now I'm going to basically use its HCF. I'm going to make pairs of like numbers. One pair, another pair right here, and that's it, right? Yeah, that's it. So the 8, you pick one number from each pair, so it's going to become 2 times 2 times 3, which is going to give you 2 times 2 is 4, 4 times 3 is 12. So the answer is going to be 12, and you're done right here. Acha ji, if it doesn't make sense, how did I decide it's going to be HCF? They said largest number that divides, its highest common factor. It's evident, okay, that it's the highest possible. And secondly, the other thing is it completely divides exactly into. So why not the LCM? Because LCM is basically kisi number ka table. Let's say I say 150. And you're basically finding least common multiple between two numbers is that one number that is common, the smallest possible number that is common in between those two numbers ka table. But in this case, we are looking for factors because factors completely divide into that number. So that's about it. Let's start the second part. The second part is find the smallest value of k such that m times k. M was given right here. Okay, so they've done a part of the working for us. They've already given us the prime factorization such that m times k is a cube number. Now here is the same concept, but now you're going to, instead of putting it in squares, you're going to put your numbers in cubes. Okay, because it's a cube number. Okay, so let's have a look. This is going to become under root 2 square times 3 times 5 square. Now in order to make all of these cubes, I would need to multiply another 2, okay, to make this 2 cube. I would need to multiply 2 more 3s, okay, to make this another 2 3s to make this 3 cube, and I'll need to multiply another 5 to make it 5 cube. Only then can I cancel out the cube, because this then will become 2 cube, this will then become 3 cube, and then this will become 5 cube. Together, all the new numbers that you multiply, 2, 3, 3 and 5, you're going to multiply them together to get the value of k, and we'll also check. Okay, 2 times 3 times 3 times 5 is 90. So the value of k is 90, and let's have a look as well. You can use your calculator for this part. This is only for checking to prove to you guys. Okay, m is 2 square times 3 times 5 square. That is 300. Okay, m as a number, this is only for proofing. M as a number is 300. 300 ka cube root does not exist. You can check as well. But if I multiply m times k, which is 90, if I multiply 90 with 300, that gives me 27,000. Now if I do the cube root of 27,000, it's a perfect cube, which is 30. Okay, so that's how you do it. You just, if it's a cube, you will make all the numbers a cube. Simple and easy. Got it? That's all you need to do. You need to make all the numbers a cube. But if it's a square root, then if instead they had said square number, then you would make all the numbers a square. Simple and easy. Make all the numbers a square. And that's it. We're done.